In this video, I wanted to further emphasize the importance that processes be stationary in their mean because of the fact that we can run into a problem in econometrics which we refer to as a spurious regression or a spurious relationship. And I'm going to explain what I mean by that. There was a study which was done by Hendry in 1980, which is well worth looking at, and it highlights this problem of spurious regression quite well. And I'm actually going to talk through this in this video. So the idea with Hendry's paper is that he was trying to explain changes in the price level across time. So there is some sort of price series which looks something like this. So this is PT. And first of all, he built a model which was using the money supply as an explanatory variable. And the money supply looked something like this sort of blue line which I'm drawing here. And sure enough, when he looked at a correlation of these two variables, so a graph of PT against now MT, he found sure enough that there was some sort of strong correlation between these two variables. And when he ran the regression, he found that there was an R squared of around 0.99. So it looks like you've got a pretty good fit there. Then what he did was he did a regression. Now he was looking at the relationship between PT, which is still the same, so it looks something like that. So this is PT. And he regressed it on something which I'm going to call CT. And I'm not going to explain what it is at this moment. I'm going to explain what it is in a minute. So this is our variable CT here. And when he then did a scatter plot of these two variables and he looked at the relationship between PT and CT, the relationship was even stronger than that between PT and MT. And actually when he ran the regression, he found that there was an R squared of, I think it was around 0.998. So it was slightly better than this original regression, which might have been 0.995. So on the face of it, he looks like he's built a better model. But here comes the sort of bombshell. The variable CT, which he was including in his regression here, is the cumulative rainfall in the UK. And quite obviously, cumulative rainfall within the UK should have no explanatory power or very limited explanatory power on prices. So why did he get this seemingly statistically significant correlation even though he had this completely spurious regression? Well, the idea was that because of the fact that both these variables were increasing across time, as we see up in this sort of top left graph, because they were both increasing across time, and even though they were independent of one another, it appeared as if there was some correlation between these two variables. It appeared like there was some sort of statistically significant relationship. And that came about because he was regressing one non-stationary variable, PT, on another non-stationary variable, CT. So this highlights the danger of regressing one non-stationary variable on another non-stationary variable. And it is a problem that we have to look out for in general when we're regressing non-stationary variables and on other non-stationary variables. Granger and Newbold in 1974, they actually came up with a relatively good, I wouldn't call it a test, it's more of a rule of thumb, which was a way of sort of diagnosing whether your model actually has spurious regression going on. And the idea that they said was that if you have an R squared which is greater than your value of your Durbin-Watson statistic, then that is very indicative of the fact that you may have a spurious relationship. Because remember, if I have a low value of a Durbin-Watson, essentially what this means is that you have large runs of positive residuals and then you have long runs of negative residuals. And let's look at this relationship up in the top right again. Essentially we can see here that we have got some runs of some positive residuals and then we're getting some runs of some negative residuals. And these are long runs of both. So if we were to sort of diagnose our problem here, we would sort of figure out that we had, well, what looked like AR1 serial correlation. Don't worry if you don't know what AR1 means, we're going to talk about it in the next few videos. But it looks like we have some sort of serial correlation, and that will be realized in the fact that our Durbin-Watson statistic will be very low. And so even though we have a high degree of R squared, which we can see from this sort of bottom right graph, we have a very low value of our Devon-Watson statistic. And that's very symptomatic of the fact that I've got two non-stationary variables regressed on one another. So the Granger and the Newbold method is a nice rule of thumb for detecting whether you have actually uncovered a true relationship between two variables, or in fact whether it looks like it is what we call spurious. It means the word spurious meaning that there is no relationship between these two variables. They're completely independent of one another.